Hey everyone, let's graph y equals negative cosine of 6x plus 8. Now remember, we already established that the amplitude was negative 1 from there, that the shift was negative 4/3 because we let x equal, we let 6x plus 8 equals 0, which implies that x equals negative 4/3, right, when you solve for x. And we know that the period is pi over 3. Well, how do we know that? Well, you can use the formula, 2 pi divided by this number. Okay, that'll give it to you. But what you can also do is you could then say, let 6x plus 8 equal 2 pi, right? The normal period of a trig function, right? Of cosine, I should say. Well, that's going to imply, when you solve it out, that x equals negative 4/3 plus pi over 3. And, well, the difference between this guy and that guy is pi over 3. So that's got to be your period. Okay? So with that in mind, amplitude's negative, meaning we're going to be flipping our graph, right? Normally cosine, just to recall, is the graph that goes like that, okay? For 2 pi. Okay? Well, let's see now. If we want to graph this, we know that the shift is negative 4 pi over 3, or negative 4 over 3. So that's negative 4/3 to the left. Maybe we'll go out a little bit further, right? So if we have 0 here, let's maybe mark, we know that our graph is going to be as high as 1 and as low as negative 1. Negative 4/3 is, maybe we go a little bit further here. I think we're right about here or so. I think that's roughly, right? Negative 1 1/3, right? It's roughly proportional. The period is 2 pi over 6, or pi over 3. So that's basically 1, right? Because pi is 3-ish, divided by 3 is 1. So maybe we would expect our graph to end right over here. Okay? So whatever our graph does, maybe here, whatever, it's going to end like that. So let's mark this on our axes. Okay? And let's think about this, right? Maybe a good idea would be to plug in a couple of numbers, right? So remembering our original function, let's plug in negative cosine of 6 times negative 4/3 plus 8, right? Now remember, that's the same as cosine of 0. That's really what we solved for, right? Or I should say negative cosine of 0, right? So that should be giving us negative 1, right? And sure enough, we get negative 8 plus 8 cosine of 0. Yep, it's negative 1. Okay, so we're actually down here for this one, right? We're down there. And as expected, right, if we plugged in negative cosine of 6 times negative 4/3 plus pi over 3 plus 8, then we should expect to get negative cosine of 2 pi, which is also negative 1. So we once again should be over there. Okay? Now remember that with cosine, we should be getting a value as high as 1, and that's when we do cosine of pi. The way to remember this is it's just right in the center, so you can really just sort of split the difference between those two guys, right, if you just remember the shape of cosine. But if you want to mark that value down, it's going to be negative 4/3 plus pi over 6. Okay. So at this point, you just sort of graph it out. Looks something like that, right? And if you want to keep it going, right, if you want to do it for maybe 2 periods, well, then you just add another one over, right? So this would be negative 4/3 plus 2 pi over 3, right? We add another period. So then we just, well, let me just put it this way. We know that we're again going to reach negative 1 over there. So we just I guess we say, well, I guess we're going to reach 1 right over here. So we do something like this. Let's try to do a little bit better sketch than that. Really try to sketch it in reverse. I think I might get a better one that way. Right, something like that. I know I'm not the world's greatest artist, right? And you can just keep doing this, right? What's the next period? Well, I'll just add another 1 over here or so. -4/3 plus 3 pi over 3, or pi. Right, and again, same sort of thing. Right, just nice, smooth graph. And again, if I'm being a real stickler, say no, I want 2 complete periods in that first quadrant. Okay, great. Well, I guess I have to do another one. -4/3 plus 4 pi over 3. All right, you happy now? Right? We have this, and we just say, oh, you happy now, Dr. Halpern? There, I've graphed that one again. Okay. So that's how you graph that.